Okay, ladies and gentlemen, let's take a look again at solving equations, but this time we're going to do it with multiplication and division. Now, multiplication and division is going to work something as follows. If I have 3x equals 9. Now, anytime we have a 3 slammed up next to an x, it really means 3 times x. Now, again, just as a side note, why would we not use that times sign when we're doing algebra? Well, the answer is because 3 times x looks a lot like 3xx, and that's not good. First of all, that'd be a massively large shirt. But it's not going to work out well. That's why we say 3 dot x, or we say 3 with the x slammed right up next to it. Sometimes we could even say 3 parentheses x, and that also means the same thing. All of those mean multiply. All of those mean multiply. Now, previously when we had addition subtraction, 6 plus x equals 4, we said, well, how do I get rid of positive 6? I would subtract 6, but if I do it to one side, I must do it to the other. So if we're reviewing back to what we've done, those are going to cancel out. X equals 4 minus 6 is negative 2. Over here, when we have 3 times x equals 9, the algebra way to do it is we say, what's the opposite of times? The opposite of times is divide. So I'm going to put a divide sign on each side because remember, whatever I do to one side, I must do to the other. And if I have 3 times x, I'm going to divide by 3. Now, I don't divide by x. I want to leave x alone. I want to not touch x. Think about x in terms of an electric fence at this point. Don't touch x because it doesn't need to go anywhere. You can't move it. It won't work. You want to move everything else from around it. Now, if I divide one side by 3, I need to make sure I divide the other side by 3 as well. So, I have now these 3 and this 3. So, times 3 and divide by 3 are going to cross out, leaving x. And in this case, you get equals 9 divided by 3. Well, 9 divided by 3 is 3. So it works out pretty nicely. Alright, so when I take a look over here, I have 4 times x equals 12. I'm going to divide both sides by 4. Divide both sides by 4. Now, the other reason this works is if I go over here and I say 2 divided by 2, you would tell me 1. If I said 5 divided by 5, you would say 1. Even if I have x divided by x, guess what it's going to be? 1. So when I have 4 divided by 4, those cross out and make 1, or 1x equals 3. So 1x equals 3. But we don't need the 1, it's just extra. You could just write x equals 3. Now, I did show you a couple other methods besides the algebra method when we did addition subtraction. So I want to go ahead and show you a couple other methods here as well. In this case, let's talk about the tile method first. If we use our last example, 4x equals 12. What I have is I have 12 little tiles or circles or pieces of some sort. And I want to break them into 4 groups. So here's what I'm going to do. I'm going to start and I'm going to take this one, put it in the first one. So he's gone. Take this one, put him in the second one. He's gone. Third one goes in the third box. Fourth one goes in the fourth box. And when I get to the bottom, I start over. And I take one and I put it in each box, just as if I were taking them and putting them in different boxes and separating them out, just like deal of cards. What do you, 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 what, etc. So, we go ahead and put everything in a box. And so now I have 1, 2, 3, 4 boxes. And how many are in each box? The answer is 3 in each box. But again, if I have any numbers bigger than about 12 or 15 or even 20, it's going to get too long to do. It's going to be a very long process. Alternatively, what we can say is, how do I take 12 items and break them into 4 groups? So 1, 2, 3, 4. 1, 2, 3, 4 groups. Well, again, I can take the 12 and go 1, 1, 1, 1. So that's 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. And there you go. You're using the bar to break them up into parts. Again, not going to be overly useful. Now, it not only works for addition and subtraction and multiplication, it works for division. So if I have this, x over 3 equals 4. X over 3 equals 4. What I've said is x divided by 3 is 4. How do I undo divide? Oh, I'm yawning here. How do I undo divide? Well, the opposite of divide is multiply. So I'm going to multiply by 3. Those are going to end up canceling out. But the thing is, I can't just multiply one side by 3. I must multiply the other side by 3. So these 3's go away. I'm left with x equals 12. Now, I could also have something like this. 4x equals 17. And I could divide both sides by 4. Gone, gone. And in this case, it doesn't go in evenly. So x is going to equal, well, how many times does 4 go into 17? 4 whole times with 1 left over. So I can make them a mixed number. I could also make them a decimal. And if I were to do this, I said 0.25 times x equals 0.75. Well, how do I get rid of a 0.25 times x? I'm going to divide by 0.25. Now, I might need a calculator, or I might recognize that 0.75 is exactly 3 times bigger than 0.25. Let's do a couple more division problems, though. X over 3 equals 11. Well, again, I have divide by 3, so I'm going to multiply. Those go away. X equals 33. I could also do it with negative signs. I could say x over negative 2 equals positive 5. When I multiply both sides by negative 2, those two negatives go away, those two 2's go away, and I have x equals, now, this is going to be 5 times negative 2. 5 times negative 2 is negative 10. Over here, I could even say negative 4 times x equals negative 20. Well, how do I get rid of times negative 4? You'll notice I'm not going to add because it's not connected by a minus sign. Even though it's negative, it's connected by times. So I'm going to divide by negative 4 in both sides. X equals positive 5. There we go. See what you can do with a couple of those. Let me give you, in fact, a couple practice problems. Okay, ladies and gentlemen, take a look at this, then hit pause, do the problems, and I'll be right back with the answers. Okay, ladies and gentlemen, take a look here. In this case, it's 6 times x. You divide both sides by 6. You get x equals 6. In this case, you have 25 equals 5 times x. So I divide by 5 both sides, and 5 equals x. Now, of course, if 5 equals x, then x has to equal 5. In this case, you're dividing by negative 3, so I multiply both sides by negative 3. 7 positive times 3 negative, so positive 7 times negative 3 is negative 21. If I have divide by negative 2 and I multiply both sides by negative 2, then I have negative 10 times negative 2, and because it's multiplied, the two negatives go away, and I'm left with positive 20. Here I'm going to divide both sides by negative 3. A positive divided by a negative is a negative 9. Okay, so there you go. Do the next quiz.